My dear students, welcome back. Let's start our revision on Classified Chapter E, the Periodic Table, Part 2. Question number 4. Okay. The periodic table can be used to classify elements. Group 1 elements react with cold water to form alkaline solutions. Place the group 1 elements cesium, lithium, potassium, rubidium, and sodium in their order of reactivity with water. Put the most reactive element first. Let's revise group 1. Group 1 start with lithium 3, sodium 11, potassium 19, rubidium 37, cesium 55. Lithium 3, so its electronic configuration 2, 1. Okay, sodium 11, 281, potassium 19, 2881, rubidium ends with 1, cesium also ends with 1. What about the atomic size as we go down the group? The atomic size becomes bigger because number of shells increases. What about the electron in the outermost shell? It becomes away from the positive nucleus. So reactivity increases down the group. Why? This is because the outer electron is getting further away from the nucleus, further away from the electrostatic attraction forces between positive nucleus and this electron. So this means the attraction is lower as we go down. Okay, the outer electron is easier to be lost from the atom, and the atom changes into an ion, positive ion. It's okay. So the answer now, which one most reactive? Cesium, rubidium, potassium, sodium, last one, lithium. Yes, right. Name the alkali solution formed when cesium reacts with cold water. From the name of this group, the nickname of this group, alkali metals. Why? Because all elements of group 1 react with cold water to form alkaline solution. What's the name of cesium when reacts with cold water? Yes, cesium hydroxide. Cesium hydroxide. Okay. The strongest alkali formed when group 1 elements reacts with water. Okay. Cesium hydroxide, CSOH. Group 7 elements are known as the halogens. Astatine is below iodine in group 7. Predict the physical state of astatine at room temperature and pressure. Let's revise group 7 or certain hints about group 7. Okay. Fluorine, chlorine, bromine, iodine, and astatine. The first two members of this group are gases. Fluorine is gas, chlorine also gas. Bromine, liquid. As you know from all periodic table, 118 elements till now. 2 elements only are liquid at liquid phase at room temperature. 1 non-metal from group 7, bromine. Okay, bromine water is liquid. Okay, what about the another element? The other element is mercury from transition elements, also liquid, but this metal. So one non-metal, the other metal, both are liquids. The only 2 liquids in the periodic table at room temperature. Bromine liquid, iodine solid, so we predict astatine is solid also. It's okay. Look at astatine. Here it is blackish, black, solid. Okay. Solid, yes, the answer solid. Look also, some group 7 elements react with aqueous solutions containing halide ions. Halogens react with halide ions. Okay. When aqueous chlorine is added to aqueous potassium bromide, a reaction occurs. Yes, the ionic half equations for the reaction are shown. chlorine aqueous plus 2 electrons reacts to give 2 chloride ions, aqueous solution or aqueous, 2 bromide ions in aqueous state, okay, combine together by losing electrons, okay, to form bromine as aqueous. Yes. Now, these two half equations represent oxidation reduction reaction, redox reaction. The type of this reaction is redox. Describe the color change of the solution. Original color of potassium bromide solution is the final color of reaction mixture. Let's revise group 7 again. Here, group 7, fluorine, chlorine, bromine. As we go down, the size of the atom becomes bigger, yes. Also like group 1 before, we discussed before. Okay, what about the 7 electrons in the outermost shell? They become more away from the nucleus. As you know, 7 electrons, all elements of group 7 tends to gain 1 electron to become 8. It is easier, more easier for fluorine to attract this electron, to gain this electron from another atom. More easier than chlorine, and chlorine more easier than bromine. So the reactivity as we go down becomes what? Becomes, as we go down, the reactivity decreases. As we go up, the reactivity increases. Reactivity increases up the group. Why? This is because the outer electron is getting closer to the nucleus. The outer electron is getting closer to the nucleus. The 7 electrons surrounding the second shell of fluorine is more closer than the 7 electrons in the outermost shell of chlorine. Okay, this means the attraction is higher of the 7 electrons. Also, it is easier to gain an electron from another atom during reaction. It's okay. Now, look, this practical application about this question, aqueous chlorine as halogen. When we add this aqueous chlorine as halogen to test tube containing aqueous potassium bromide colorless halide as halide, what happened? Yes, bromine water is released as in the second half equation in the question with orange color or red color. Okay, this reaction called displacement. What is meant by displacement? Displacement is a type of reaction where more reactive halogen will take the place of less reactive halogen from its compound. So when chlorine meet bromine in its halide salt, chlorine replace or displace bromine, okay, in solution, okay, and take the place of it. So look, original color of potassium bromide now, colorless. What about final color of reaction mixture? Here's this reaction. Chlorine, when we add chlorine to potassium chloride, nothing happened. So cross. When we add chlorine to potassium bromide, what would happen? The chlorine displace bromine and take KCl as salt, as halide is formed, new halide is formed, potassium chloride instead of potassium bromide, and bromine is displaced as Br2. What's the color of Br2? Orange, red, brown, like this. Look, yes, this preserved as sample containing bromine liquid at the bottom, and yes, at the top of this tube in this model. It's okay. With orange, red, brown, all these answers are good. Let's start second question. Question number 5 from exam 43, May, June 22, question number 6. The periodic table can be used to classify elements. Yes, the group 1 metals react with cold water. The transition elements do not react with cold water. Yes. Describe 2 other differences in the chemical properties between group 1 metals and transition elements. Look. Number 2, 2 other differences. We can answer from this table. Group 1 elements, its chemical properties, fixed oxidation state, all carry 1 positive charge when they lose 1 electron, okay, their outermost electron. So fixed oxidation state, positive 1. High reactivity, they react vigorously or with different strengths with cold water. Non-catalytic properties, they have no catalytic properties, okay, while transition metals each one has variable oxidation state, less or no reactivity, like gold, like platinum, okay, less reactivity or no reactivity, Catalytic properties, they have catalytic properties, act as catalysts in many industries, as we'll see in our course. Any 2 of these differences of group 1 metals can be answered here. Now, the periodic table can be used to classify elements. The group 1 metals react with cold water. Transition elements do not react with cold water. Describe 2 other differences in the chemical properties between group 1 metals and transition elements. 2 other differences with 2 marks. Here, group 1 and transition metals, he asked about chemical properties, not physical. So group 1 metals all have fixed oxidation state with positive 1. When they react, they tend to lose 1 electron. So their oxidation state positive 1. Higher reactivity, they react easily with water, with cold water, okay, and also react with oxygen, atmospheric oxygen easily, okay. Non-catalytic properties, they have no catalytic properties, while transition metals, each transition metal has variable oxidation state, okay. Less or no reactivity. Most have catalytic properties like vanadium pentaoxide, V2O5, like iron, okay, like nickel, Ni. All these metals are transition and has catalytic properties. It's okay. Now, describe. Double I describes the observations. Observation depends on your sense organs. Observations when potassium is added to cold water. Write a balanced chemical equation for the reaction, include state symbols. Here he asked about observations. Write a balanced chemical equation, include state symbols. Okay? This question is big marks, okay, with big marks, 5 marks. So, observations. What about this observation when we add potassium to cold water? Look. Yes. We depend on our sense organs. We can see, we can hear, not taste. Okay? Yes. Observation. Fruits the piece of potassium floats on the surface because it has lower density than water. Okay, floats, not sink. With ever-sense of gas, a lot of gas is formed, is released. This gas is hydrogen. With ever-sense of gas, don't mention that this gas is hydrogen. Just observation depends on what you see, what you hear, okay, what you feel, and so on, what you smell. With ever sense of gas, what about the color? It catch fire. It catch fire. Potassium piece catch fire. Okay, form a pool of metal on the surface of water. Okay, and catch fire with lilac flame. Lilac flame. This color of flame is lilac flame. It's ideal for potassium when is added to cold water. Okay, this observation. What about chemical equation? Include state simple. Block potassium, potassium as solid piece. Small piece of potassium is added to cold water. Here, the state symbol S for solid, L for liquid water. Here, reacts to get potassium hydroxide, KOH, equals ionized plus H2 gas. This state symbol mentioned in the equation. What about the balance? Let's learn how to balance the chemical equation. Here, in hydrogen, we start with 2 hydrogen in water as reactant, 2. We find here 1 hydrogen in KOH and 2 hydrogen in hydrogen released as gas. So the reactants 2 hydrogen, the products 3 hydrogen. How come? So we change the odd number of hydrogen in KOH instead of 1 must be even number, so we have to multiply by 2. So 2 here, 2 on the line, 2 is factor, 2 moles of KOH. So now the hydrogen becomes 2, right? And the hydrogen gas still 2. 2 plus 2 equal 4. What about the left-hand side of hydrogen? Okay. We have to multiply 2 here also. Okay. Then multiply 2. What about potassium? Also 2. So we start with 2 potassium, then times 2. So we have to put 2 in front of potassium. Okay. Now, transition elements. Sorry, transition elements are stronger than group 1 metals. Transition elements are stronger than group 1 metals. Stronger in what? In picture, stronger in strength. Describe 2 other differences in the physical properties of group 1 metals and transition elements. In physical properties, don't chemical transition, physical properties. Look here, group 1 metals and transition metals. What about physical properties? Group 1, softer, harder or stronger for transition, not mentioned in the answer now because in the question he mentioned that transition are stronger than group 1 metals. So don't mention softer or harder. But we can mention the 2 of the other 3 properties: lower density for group 1, lower melting point for group 1, colorless solutions. They form colorless solution, alkaline solution. All they are colorless. What about transition metals? They are harder, higher densities, higher melting points, color solution. Look. What about softer here? Softer, we can cut piece of sodium with knife or even sharp or hard fingernail. Okay. Look at the surface sodium from outside is dull because it reacts with oxygen. Just we take this piece of kerosene and put in table subjected to air. It reacts vigorously with oxygen and forming certain layer of sodium oxide, dull in shape. What about in the center of this piece, shiny, this fresh sodium, okay, shiny metal, okay. Look also about the color. Transition metals characterized by different color solutions. Here, iron-3 chloride, cobalt chloride, nickel sulfate, copper sulfate, iron-2 sulfate with different degrees of colors. Okay. What about sodium sulfate? Example of group 1 salts solution, colorless solution. Okay. Okay. Some group 7 elements react with aqueous solutions containing halide ions. When aqueous bromine is added to aqueous potassium iodide, a reaction occurs. The ionic half equation for the reaction are shown. Bromine equals plus 2 electrons, gain 2 electrons, and they become 2 bromide ions equals in solution. 2 iodide ions in aqueous potassium iodide, they lose 2 electrons, they oxidize to form iodine in aqueous solution. Okay. Describe the color change of the solution. Original color of potassium iodide, the salt of group 1 solution, so colorless, must be colorless. Okay. Final color of reaction. Look, please, and let's revise. As we know before, group 7, reactivity increases up the group. So fluorine is reactive than chlorine. Chlorine is reactive than bromine. Bromine reactive than iodine, and so on. Okay. So, what about when bromine here, okay, react bromine is added to aqueous potassium iodide. Potassium iodide. Bromine is reactive than iodine, so it replaces or displaces iodine. Displace iodine, eject iodine from its salt, from its halide, as I2 here, as I2. What's the color of I2? Okay. Each element in group 7 displaces the next one below. Why? Because it's higher in its activity. Okay. Look, potassium iodide is colorless. So the answer here, colorless. All solutions of group 1 salt solutions are colorless. Okay. Final color of mixture, look, here, bromine water is added to potassium iodide. What's the color change here? It becomes what? Brown. Iodine as brown solution. Okay. This explains the displacement reaction as mentioned before. It's okay? Okay. Question number 6. Now, when potassium is added to water, it reacts vigorously and the color flame is seen. The equation for the reaction is shown. 2 potassium as solid reacts with cold water to form potassium hydroxide and the hydrogen gas is released. See the color of the flame seen. Okay. Look, we mentioned this before. The color, yes, lilac. Lilac. Okay. When potassium is added to water, it reacts vigorously. It's okay. Double I, the solution form is potassium hydroxide, strong alkali, strongest alkali, okay, in group 1, KOH. State the formula of the ion responsible for alkalinity in solution. See the formula of the ion responsible for alkalinity in solution. The ion here is hydroxide ion, OH minus. This is responsible for alkalinity. Okay, alkalinity, OH minus 1. Now, when potassium is added, triple I stays the color of litmus in strong alkali. When we add litmus paper to solution containing potassium hydroxide, look, and blue litmus paper change, sorry, red litmus paper change into blue, okay? Changes into blue, look, blue. KOH solution, when we put 1 drop of KOH on red litmus paper change at once into blue, while blue still blue. Okay,